Okay, welcome to Strong Tree Academy final review packet problem number 34. So here we're asked to find an equation of a circle having these 2 points as a diameter, these 2 endpoints of a diameter. So again, on all these write the equation problems, this is going to look not so good here, but I always like to make a little sketch first. So let's put these 2 points on here. 2 over 1, 2, 3, 4, 5. So that's one endpoint of our diameter, and then we have -2, so -2 over, 1 down. That's our other endpoint. So if I was going to sketch this in, I'm going to sketch it in kind of in red. Let's just connect those lines. Our center would be somewhere around here, and then we'd have this terribly drawn circle right here. So anyway, that's the kind of picture we're looking at here, and let's remember what the equation of a circle is. That's just x minus h squared, where h is the x-coordinate of the center, plus y minus k squared, where k is the y-coordinate of the center, equals the radius squared. No, so what we need to find to write this equation here, we need to know the center and we need to know the radius, and we need to find those two. We're not given either of those things directly, so we need to find them. Well, the first way to get the center is just to realize that that's going to be the midpoint of the 2 points on the diameter, right? That's what it means to be a diameter. It's something that goes through the center of a circle, and so the midpoint of those 2 spots, or those 2 points, would just be take the average of the 2 coordinates. So if on the x side we have 2 here, minus 2 divided by 2 to get the average, and then here we have 5 minus 1 divided by 2 to get the average of the y coordinates. And that equals 0. And then 5 minus 1 is 4, divided by 2 is 2. If we look at our sketch, it kind of looks like 0, 2 is about the right answer. So that passes the reasonableness test. So that gives us our center. Now we just need to find the radius. And here we just got to use straightforward application of the midpoint formula. We can, since we have the coordinate of the center, we can just find the distance from the center to one of these points. So let's do that. We have point A, which is 0, 2, point B, which we'll just pick 2, 5, which is, we'll put this one out here, B, A is the center, and let's just find the distance between those. That's going to be the square root of, we'll do B minus A here, 2 minus 0 squared, plus 5 minus 2 squared. That's going to be our radius, and then 2 squared is 4, plus 3 squared is 9. So radius is going to be root 13. R squared, what we need for the equation, is just going to be simply 13. Write the final answer in green here, so we'll just use that. We have x minus the y coordinate, x coordinate of the center, which is 0, so we'll just keep that like that, plus y minus 2 squared. We have 2 as our y coordinate of the center, and here we have r squared equals 13. And that's the answer to this problem. On to problem 35. So this one we're asked to find the length of a tangent line segment from the point 10, 5 to the circle x plus y squared, x squared plus y squared equals 25. Well, from here we know that that's r squared, so we know the radius of this circle is going to be 5, and this is a simple circle. It's centered at the origin because there's no x minus h or y minus k, or h and k are 0. So if I go ahead and sketch that in red here, our circle is just going to go through, it's a radius of 5. 1, 2, 3, 4, 5, 5. And so that will be the rough sketch of our circle here. Again, not so good. It's hard to do this on a tablet. Sorry about that. And we have this point out here. I'll draw it in green. Call that point P. It's 10 over 5 up. So here's our point P, 10, 5. We need to find the length of the tangent line segment. Well, the tangent line segment is going to, there's actually 2 of them. Something here, it meets the circle in exactly one spot, and you can see that it's going to happen in 2 different spots here. Not going to matter which one we choose. I'm actually going to use the bottom one here. But we're trying to find the length of this guy, and it's intersecting right here. This is where you need to resurrect a little knowledge of geometry. We know that the radius of a circle will intersect its tangent line at a right angle. So that's an important piece right there to being able to solve this problem. And we know that because this radius of the circle is 5, we know that this particular line segment here is 5. And we're trying to really find the length of that segment. So that suggests to me that we want to make a triangle because we have two pieces here. So let's go ahead and I'm going to draw this line segment in from the center out to point P. And it looks like that would be easy to find the length of that segment, right? We know the center here is 0, 0. This point is 10, 5. So let's just do the distance formula to find the total length of that segment. It's going to be 10 minus 0 squared plus 5 minus 0 squared. The entire thing square rooted will be the distance between the center and P. I'll call that the center point C. And that's just going to be the square root of 100 plus 25, which equals root 125. So now we know that this line segment here is root 125. And then it's just a straightforward application of the Pythagorean theorem here. We have a right triangle here. You can see this is the right angle. That root 125, it's the hypotenuse. I'm going to call the thing we're trying to find here x. Sorry, not x squared, x. That's the length of this line segment. So to find that, we're just going to do x squared plus this leg, which is 5 squared, equals the hypotenuse, which is root 125 squared. Now we just solve for x, and that's what we're trying to find in this problem. X squared plus 25 equals 125, x squared equals 100, and x equals 10. That's the answer to that problem. Really, the key part here was just remembering some facts about geometry and how to interpret the equation of the circle here and sketch it out.